Hey peeps, Julian here from Tutoring, and as always, it's such a pleasure to join you. We are now on question 10 of the DBE Math Paper 2, 2019, which is a Euclidean geometry question. And question 10.1 is, they've given us a diagram with ABC, the triangle, and triangle DEF, in such a way that angle A and angle D are equal, and that B is equal to E and C is equal to F. And then they're saying use this diagram to prove the theorem which states that two triangles are equiangular. So if they are equiangular, then the corresponding sides are proportional, so that AB, which would be this, over DE should equal AC, that side, over DF. So in order to start this proof, we're going to construct a triangle within ABC. Let's call this point M and point N, such that this line is gonna ensure that AM, so AM is going to equal DE, and that AN is going to equal DF. So this line, that line are going to be the same size, and this line and that line are going to be the same size. So we've constructed that, so we can then, and that's also given that the angle A is equal to angle D, because remember over here it's given. So using these three pieces of information, we can conclude that therefore triangle, so the first one A, well at the top, so AMN, so it's this triangle over here, AMN, is congruent to triangle DEF, and the reason being is by construction this it's side and then angle side. So your reason here for congruency is side, angle, side. And now that we've proven congruency, we can conclude now that the angle B and your angle M are going to be equal, because congruent triangles have equiangular, or have equal angles. So therefore, we can conclude that AMN is equal to angle E, which is equal to B. So as I said, so it's also equal to this E, because of course this E is the same triangle as MAN. So using this information now, we can conclude that line MN is parallel to BC, and that's because of the converse of corresponding angles. So this line here is now parallel to this line here, because B and E are equal. So the reason being corresponding angles are equal, using your triangle theorem. And now using the theorem, lines parallel to one side of a triangle are proportional, we can conclude that therefore the side AB over AM should equal AC over AN. So basically, so yeah, AB, so it's this line over here, to AM should be proportional to AN over AC, or AC over AN. And your reason here should be your theorem that lines parallel to one side of triangle are proportional. Cool. And remember at the beginning we said that AM equals DE and AN equals DF. So therefore we can substitute that in for AB over DE equals AC over DF, which is what they wanted us to prove. Moving on to 10.2, and it's given us a diagram with O is the center of the circle and CG is the tangent. Piece of important info is that DOE is perpendicular, so it's forming a right angle at angle O, and some other information which they've drawn onto the diagram. And then they've asked us to prove that DGFO is a cyclic quad. So first off, we know that angle DOB equals 90 degrees. As I said, DOE is perpendicular to CA, so we know that that's given. And we also know that angle DGF equals G3 plus G4, as we can see in the diagram. So basically this angle here, and we know that this equals 90 degrees because we can see that it is a semicircle, a triangle in a semicircle. So you can see that triangle there, and it's in a circle, in the semicircle. So, as I said, the reason being here is angles in semicircle are equal to 90 degrees. That's the theorem. So then we can therefore conclude, that DOB plus DGF will equal 90 plus 90, which equals 180 degrees. So therefore, in the circle that would form around, as I said, this DGFO will be the circle here. We know that the angle of DBO, which is this one, and DGF, which is this one, sum to a 180, which means that the theorem, it's a converse of opposite angles of a cyclic quad are equal to 180 degrees. So therefore, DGFO is a cyclic quad, and your reason here is the converse to the theorem that states opposite angles of cyclic quad equal 180 degrees. And we're moving on to B. They're now asking us to prove that line GC equals CF. So that's this line here, GC equals CF. And in the previous question, we just proved that GDOF is a cyclic quad. So So we then know, we can conclude that F1 should equal angle D because of the theorem that exterior angles of a cyclic quad are equal. So I'll write that down. F1 should equal D, and your reason, exterior angles of cyclic, or of a cyclic quad. Okay, and then we can also say that G1 and G2, which is this angle here, if you look at that big circle again, it is part of the tan chord theorem of the triangle DGE. So we then can conclude that G1 plus G2 will equal D, and this is the tan chord theorem. So tan chord theorem. And from that we can conclude then, therefore, F1 should then also equal G1 plus G2 because they both equal D. And from this we can conclude that GC equals FC, and that's because of it's an isosceles triangle. And the reason is that sides opposite angles of an isosceles triangle are equal. So this is the converse to that theorem. So we basically there that GC should equal FC because F1 equals G1 plus G2. And on to 10.2.2, they said it's further given that OC equals 11, so O till C equals 11, and that DE is 14 units. Now we need to calculate the length of BC. So first off, DE is a diameter, and we also know that AB is also a diameter. So DE equals AB, and it says that DE equals 14 units. So therefore, AB equals 14 units. OB is the radius of the circle, so that's going to be half your diameter. So therefore, OB will equal AB over 2, which equals 14 over 2, which is of course 7 units. We further know that this line BC is the difference between the line of, so BC will equal OC minus OB. And we now have, they've given us what OC is, and we've just calculated what OB is. So you see it's the difference between the two lines. So this is going to mean that it's 11 units for OC minus 7, which equals 4 units. Okay, and then on to B. They now want us to calculate the length of CG. So CG is this line over there. So we can start off by saying that if we look at the triangle CGB, so in triangle CGB and triangle CAG, so the triangles I'm referring to here are, I'll just highlight them. So it's C up to G and down to B, so it's a small one here, and the other triangle is C up to A back to G. So those two triangles, we're going to prove that they are similar. We can do this by stating the fact that G1 equals A, and we know this because of the tan chord theorem. So you can see there that G1 is equal to A, and it's because of this. Remember, GC is a tangent to the circle, so the reason being here is the tan chord theorem. And then, of course, angle C is equal to angle C because they're common. That's your reason. And the third angle is assumed to be equal because of the angles of a triangle equal 180. So remember, when proving two triangles are similar, you just need to prove that two angles are equal. So we can say that CGB is similar, this is triangle, to triangle CAG. And the reason is angle, angle, angle. So now that we've proven the similarity, we can now use the fact that the ratios between the sides of the triangles are equal. So CG over CA will be proportional to CB over CG. So if we look there, that this line here, CG over CA, which is that long line there, will be proportional to CB, which is the small one, over CG. So using that fact, we can substitute that CA is, remember, AB, they've given us as, remember in the previous question, was 14 degrees, or 14 units from over here. Remember, we stated this. So, and you can see that BC we calculated to be 4 units. So the line CA should be 14 plus 4. So I'll just put this here. CA will equal 18. And of course, CB from the previous question we calculated to be 4. So CG over 18 will equal 4 over CG. Do a little bit of algebra, get the CG squared because it goes up to the top, equals, and it'll be 4 times 18, which is 72. And then we need to find the square root of CG squared to get our final answer of CG equals the square root of 72. And if you put that in your calculator, you can get it as 8,49 units. And that's the answer for B. And finally on to C. They're now asking us to find the size of angle E, which is this angle over here in the triangle. So we can start off by stating that OF, which is from here, from the center to F, will equal OC minus FC. Okay, and we know that OC equals 11 and FC equals GC. Remember back when we had to prove that was the truth in this question, number B. So we also know then that GC equals, from the previous question, it's the root of 72. So we can then conclude that OF equals 11 minus the square root of 72. And if we look at this triangle with that, it goes EOF. If we take the tan of E, that's going to be the opposite over the adjacent, which will be, so basically tan of E would equal OF, which is your opposite, over adjacent, which is OE, and we have those two values. So tan of E will equal, we just said OF was 11 over the square root of 72, and we know that OE is 7 because we calculated that back over here, that OB equals 7, or rather OB is equal to 7, which is the radius, so therefore OE will also equal 7. Go back to our solution. So we can say that OE equals 7 because remember OE is the radius. And now we can do the inverse of tan. So we know that angle E will equal the arctan, so tan to the minus 1 of 11 over the square root of 72. Well, 11 minus the square root of 72 over 7. If you put that in your calculator, remember shift tan to get your tan inverse. I get the answer of 19,76 degrees. And that's the answer for E. That concludes question number 10. Before I go, I'd just like to give a thanks to our epic sponsors for making this video possible. You can read more about them in the description below. Be sure to visit our website for more tutorials such as these. And if you can't find the answer to the questions you have, remember to send us your question and we will respond with a personalized video just for you. And until then, stay epic.